So, chapter 3.4, example 13. Hopefully you've looked at the introduction so you know the equations that you need to know for a geometric series. So we should be thinking Sn equals a lots of 1 minus r to the n over 1 minus r. That's the sum of the first n terms. The nth term is a times r to the n minus 1, and the sum to infinity equals a over 1 minus r, provided the modulus of r is less than 1. So they're the key facts we need at the start of this question. Find the sum of the following geometric series. So we're in a sum question. So the sum, so we're going to be using this equation. So we're going to start by stating as usual. So state Sn is equal to a lots of 1 minus r to the n over 1 minus r. We can see a is equal to 2. That's the first term. We can look at the common ratio. So we are multiplying by 3. Check, multiply by 3, check, etc. So r, the common ratio, is equal to 3. And we're told in the question that n is equal to 10, the number of terms. Okay, so the number of terms is n. So we can now substitute in. So S10 is equal to a, which is 2, 1 minus r to the power 10 over 1 minus 3. So we get 2 lots of 1 minus 3 to the 10 over negative 2. So the 2's cancel, divide by the minus 1, we've got 3 to the 10 minus 1. Not straightforward, 3 to the 10 is not something I know off the top of my head, so I'm going to have to tap that in the calculator and subtract 1. So we get 59048 for part A. Part B. Again, it's a geometric series. Again, it's a sum. So we're going to have to use the same equation at the start. I'm not going to write it out again. It's already there, but that becomes our state phase again. Now, there's more than one way of doing this, because we could start at the right-hand end. Yeah, there's nothing to suggest that when we've got the whole series that we have to start with the first number. So we could think of this as 1 and increasing. Yeah, so we could think of it as 1 and increasing, but we will do it the standard way, which is working backwards, or working along the line here. Yeah, so RA, our first term, is 1024. A equals 1024. R equals, the first thing to notice is that the signs are changing, negative, positive, negative, positive. So R must be negative, and 1024 and 512. Well, if we do 512 over 1024 equals a half. It's just the second term divided by the first term. Second term divided by the first term to give us the ratio from one to the next, and check that we get the same. 256 over 512 again is a half with the change of sign. I've lost the minus sign off there. Okay, and so we've got A and R, but to find the sum of the series we also need N. Well, for that, we're going to have to use our rule for the nth term. So un equals ar to the n minus 1. We know our nth term is 1. So 1 is equal to 1024a r negative a half to the n minus 1. Okay, so we get 1024 is negative a half to the n minus 1. Now the term with the unknown power is on its own. Yeah. Term with unknown power on own. Now take logs. Oh, excuse me. Okay, so we take logs. Log to the base 10 of 1 over 1024 is equal to log to the base 10 of negative a half to the n minus 1. Okay, we can use our log laws to bring the power down. So we've got n minus 1 equals log of negative a half. Divide, so n minus 1 is equal to log to the base 10 of 1024 over log to the base 10 of negative a half. We can tap that in the calculator and get a value out, which should be 10. So n equals 11. Now we've got 11 for n, we can go back and use our sum of the first n terms. So S11 equals A, which was 1024, times 1 minus R, which is negative a half, to the 11 over 1 minus negative a half. So we've got 1024 times 1 minus 2 to the 11 is 2048 all over 3 over 2. And I got a slip in there. Here, that should have been plus, because a negative to the power 11 is negative. Negative times a negative is plus. So we've now got 1024 plus a half all over 3 over 2. Invert and multiply. So we get 2048 over 3 plus a third. So 2049 over 3, looks like it divides by 3, so that will give it, because the sum of the digits is 15, so it will divide by 3, so we've got 6, 8, 3. That's the answer.